Hello, good morning everyone. Today we are here to on a new session on AZ-204 course. So my name is Rishav Chatterjee. I'm currently a developer in Physics Expired Technologies, and I'll be conducting this session today. This session is on the blob storage on Azure, which is which is a storage uh, container that we use to store uh, unstructured data as text and uh, binary data files. So, and this course is on a Azure exam, which is Azure 204, which is a Microsoft certification course. And we here at 365 are preparing for it and hope. And this session is recorded to uh, like guide anyone interested in the process of our journey to through the preparation. Just on a recap, this is a course structure, and today we are on a blob storage. So in this course, we are going to learn how to create Azure Blob resources and how to manage them, and what storage containers are in Azure and what we can do with them, and what other libraries we can use to uh, connect our .NET applications with Azure. Currently, we have three models for this session. The first one will be exploring Azure Blob Storage. In that we will cover what blob storages are, why do we need them, and what different types of storage functionalities available in Azure. The second one is managing Azure Blob Storage, like we can how we can manage the storages which we have created as per our needs. Like each storage containers, each storage data blobs has different kind of necessities for the application. Like, do we need them regularly? Like, do we need how much access do we need? Like, is it in an archive mode? Is it like in a current mode? Like that. So we have something called a lifecycle management for storage containers. So we will be covering that. And in the last, we will be going through a demo application, which is a .NET application, which we will be connecting with our storage container that we will be making. And with it, we will be trying to upload some data, a text file, and then using Azure Client Library, storage client library, will be uploading that data, downloading it, listing how many data blobs we have in the storage container, then deleting it. So thank you guys for joining in. Let's move on. So there are two kinds of storage accounts basically. So a storage account is provided is a resource service provided by Azure, which we can use to which we can use to put data into. Like it is a like we have a relational database for structured data, the data for which we know what the where the data type is predefined and we know its structure. That is called as structured data. And when it comes to unstructured data, we don't know its type. Like it's not relational. It can be a file, it can be a text file, it can be an image, it can be a video file or a music. So it can be binary data, text file. That kind of file is called unstructured data. So that a relational database, typical relational database, is not a good choice to store those kind of data. So here comes Azure storage accounts with blob data types, which we can use to store those kind of data. And in storage accounts, we have two kind of storage accounts that we can have. One is a standard storage account, that we can use, and another is a premium account. In a standard account is what we get normal hard disk drives, which is like disk storage, and in a premium account we have solid state drives. Premium account usually like we have solid state drives, so the throughput and the performance will be very much higher than standard, as will be the cost. So while creating a storage account to store our data, we have a choice to select which type of storage account we want to create. If we select a standard storage account, we have a general purpose V2 account, which gives us a couple of types of storage functionality. Like we can store a blob, we can store a queue, a table, and so on. And in a premium account, we can only store blobs, page blobs, and file shares. We'll be going through what page blobs and block blobs are in later slides. So moving on. And this is a now we have access tiers of blob data. So previously, as I said, blob data is a type of data type that is available for storage, that is available in our storage account. So in a blob data, we have three tiers. So every data in an application has different type of has a life cycle in itself. Like a data, when it is first created, it will be like used very much, like it will be uh, fetched or it will be read by the users. And as it ages, its demand or the usability of the data decreases. There like and after like 30 days or 40 days, it will not be used anymore. So for that kind of a use case, we have different tiers of data, tiers of management for the data. Like we have hot tier, which is where when the data is frequently accessed, and the like and the and we want like least amount of access time. So hot access tier is costly as per the storage is concerned. Like if you want to store very large data in hot tier, it will be costing us, but the cost of accessing it is very low, so that we can access fast data, but the quantity of data is low. And then comes the cool access tier, which is after the hot, where we can move our data up when it ages like 30 or 40 days as per our business requirement. And it is slightly slower than the hot access tier, but it is also faster. It is also very much faster. And then comes the archive tier, which we can move our data to when it is like 180 days at least, or when we feel that we don't longer need the data. In an archive tier in block data type means the data is no longer readable. It is there in the cloud, but it is no longer readable by it can't be queried. So so that is archive tier. And then we can, if we choose, then we can also delete the data if we no longer need it. Moving on, blob storage resource types, which is the nomenclature and the how the hierarchy is of a storage account. So this is a storage account which we discussed. There are two types of it. One is a premium and one is a standard. So when we name a storage account, then inside the storage account we can have n number of containers. Like we can give names to the containers as per our requirement, and inside the container we can have blobs, a blob, and we can have as many types of blob, like number of blobs as we want in a storage container. And inside a storage account, as when we are making a storage container, we have to make sure of it that the names of the storage container is unique, so that there is no conflict when we try to query it via storage client library. We also get many security features when we store data into Azure storage, when we use Azure storage as our uh, go-to storage facility. Uh, by Azure storage, we get Azure Active Directory as default. Like we can give role-based access control to our users in our organization. And also data is secured in transit. Like when data is shared among users in the organization, it is we can be sure that it is secured, and uh, and we can also use shared access signature for users which are not in our organization to give them delegated access. And in shared access signature, we can also create like limits and expiry periods for the URLs that will be generated for a storage account or a container. We can give access to a single blob, a container, or a account, I guess. And then there is also encryption on storage. So a very good facility, like good feature of using Azure storage is we get encryption by default. Like we don't have to uh, implement, or we don't have to get into the encryption process. Like we can be rest assured that whenever a data is getting uploaded as a blob or any data type into Azure active Azure storage, the data is automatically encrypted. And all new and old storage accounts, there is this facility of encryption, and we can't disable them that even if we want it. And we can think that if there is encryption, the performance will be hindered, but that is not the case here. Encryption does not affect performance in Azure storage. So that is a nice security feature to have. Moving on, the redundancy options. So whenever we want to store anything, our data, application data, it is it is very important to us. Like we want to be sure that that data will not be lost, be some case arises. So the redundancy option which are given to us in Azure storage are two types of redundancy options, which is one is primary region and one is redundancy in secondary region. What primary and secondary region, the difference is that whenever we create a storage account, we get a option to set which region that data will be stored in. Uh, that region being a physical region like North America, Central India, or any other geolocation. So that the single region that we select will be our primary region, and we have an option. We have an option to select uh, as we select a primary region. Whenever we upload a file, we have a option to and we also set the option what the redundancy option will be for the storage account. Like will the file be locally redundant? Will the file upload will be using LRS or ZRS? By LRS we mean that that file will be uploaded in the only the primary region only. Like the default version of it is like it will be uploaded it will be copied synchronously 3 times in the primary region of our selection, in the primary geolocation of our selection. And then comes the ZRS, which is a better alternative from LRS. So what it does is it copies the data 3 times in the primary location, uh, 3 times in the primary location, and also the Azure zones that we have, which is like 3 Azure zones, like in the primary location of a selection. And then moving on to secondary region, which is first is geo redundant storage. In geo redundant storage, we we synchronously copy our data 3 times in the primary region of a selection. Then we asynchronously copy into a secondary region of our selection. The secondary region of our selection will be mentioned when we uh, make our storage account. So it will be asynchronously copied to secondary region of a selection, and then LRS will be applied, which is copying it 3 times into that secondary region, and that will be done synchronously. And the same for the GZRS, which is the data will be copied 3 times in 3 different zones, Azure zones, in our primary location, and then synchronously copied to 3 different Azure zones in our secondary location. So as we move down from up to down, the data redundancy increases. So why do we need secondary region? As we have already have primary region, because we can be rest assured that even if like something fails in a location, like in something, the data center in India, central India fails, and I have my secondary region set to North America, then I can be rest assured, even if something, some natural calamity happens and the data centers get destroyed in India, we can always like revert back to the data that is already copied in our secondary region. So it is quite important for like important data which we don't need, like we don't ever want to give a chance for it to get destroyed. So these are all the redundancy options we have in Azure storage account. Moving on. Sorry for that. Moving on, we have Azure Blob Storage Lifecycle. Sorry, let's just create a storage account and see for ourselves the options that we went through here. So this is the Azure portal. And to create a storage account for ourselves, we first need to go from the dashboard. We can see Azure Storage is right here. Or if we don't find it, we can go to all services. You can see storage account here, and also you can search storage accounts. Create a new storage account, press create. It will be giving us an option to create, like select a subscription. We are using the free trial for my account. So we have to fill these details of our storage account. It says the storage account name must be unique. As I said, the container name inside a storage account must also be unique, and also the storage name in a single directory should also be unique. Like we can't have two same name storage account in a single directory AD. For the region, I'm selecting India. Uh, we have an option to select the performance, which is standard and premium. The standard one is the hardest one, which is like the throughput is like it will be good for most scenarios, but if we want a better experience with low latency, like some applications need real-time updates and stuff, like video games, like online video games or streaming services. So we will be needing premium account for that. So gonna set it to standard. And here we have an option to set redundancy. As we discussed earlier, we have two options of LRS and GRS over here. So the basic one is LRS. We select review and clear, and it gives us an overview of all the all the options that we selected, which is subscription and all the storage account names and stuff. So if we hit create, our storage account will be created. Says initializing deployment. Yeah. Says deployment succeeded. Go to resource. Here we can view the properties of the our app's storage account and monitor what is the like average latency stuff. So this is how we create a storage account in Azure. So moving on to heads, we have Azure Blob Storage Lifecycle. So what lifecycle basically is moving a data through different stages of its life, like moving from hot to cool and then to archive and then ultimately getting deleted or being there in archive forever. So why do we need that? So we need it because the demand or the need for a data decreases or increases as time goes on. Like when a data is created first, it will be needed. It will be needed much more than when the time moves on. To give an example for that is, let's say, yeah, like when we book a train ticket. So when we book it, we might try to access it again and again, and then after we like travel and the thing is done, then we no longer need it, but the data is still there. Or our bank account details, like if we try to go to the last 180 days or a year of our like the last passbook, we can uh, review that, but any longer than that we have to like visit a bank. Like it depends on the which bank we are using, and so the data has to be stored somewhere. So for that we have a storage lifecycle defined. So to ease out that process of storage, we have defined we have a storage lifecycle in Azure, and we can also do like set the lifecycle from our Azure portal and also Azure CLI, which is command line environment, which we have here. Just so, and why do we need to like move the data from one tire to another? Like the hot tire is pretty expensive for a data. Like as the data grows, we don't want to keep the big amount of data in hot tire. So we can manage our costs also that way, to like moving only the required bit of data to the required to their respective tires. And we can also define rules. By rules, we mean that uh, the rule will be run once a day, and as per like if the data, the rules can be like is the data when the data was last modified, when what was it created, uh, and we can also set the after some time, like after 10 or 20 days, the data will be deleted or moved to somewhere. And we can apply those rules, the rules that we set on a storage container that for a blob. We can also apply those rules for a subset of blobs inside a container or to the whole container itself. And we will see how we can do that using Azure storage lifecycle tool. So these are the policies that we have with uh, lifecycle policies that we have, and the lifecycle policy is nothing but a array of rules, and each element of that rule is an object. And for that object, we have its name and its different properties. And inside the properties, we have the most important one is the definition part. So, and inside definition, we have actions and filters. The filters is which blob or the container this rule has to be applied to, and the action is what action has to be taken if it comes to true, if it matches with the our action. So as we can see here, some example rules are like days after modification greater than. So if uh, and going to the filters first. So in filters, we have an option to prefix match. So what it does is we have a container one slash foo. So container one is the name of the container, and slash f foo is the name of a blob. So what it means is like inside container one, all the blobs which is prefixed, which starts with f will be matched with this rule, like with this action. So it will go to container one and check all the blobs which starts with foo, and it will check that this actions on them, like is the like days after modification greater than 30, like is it true, like days after modification greater than 90. Like if this is true, then the tire will be set to cool. Like if it is hot now, like by default, I think it sets. And also one thing is that when we upload a blob or any file in a storage container, we can set its tire then and there. Like we can set it to uh, cool or hot as we required. So we can set the policy there also. Like on upload, what will be the tire of the data. So currently we have when the tire will be set to cool, when the tire will be set to archive, and when will be deleting. So here we have the modification day will be is set to 30, and the or to archive is set to 90. So it will be the tire will be set to archive if the modification is like any modification is not done for 90 days. Like it is the file is not touched even for 90 days. Then we have the delete action, which is done when the file is not modified for 255 like 2555 days. So that's what we have set, and we can change that as we go. And also, as we mentioned earlier, the archive tire is pretty much offline. So we can't view the data, like we can't try to sync, like access that data if we want on like cloud or real time. So if we need for any reason to rehydrate our blob, we have to first move it to an online tire. By online tire, we mean it must be moved to uh, hot or cold tires. Uh, so there are two ways we can move, like rehydrate a blob to online tire. We can copy that single blob to another blob which is currently online, or we can go and change the access tire to online. We also can use this thing like changing the blob's access tire to online can be done via Azure portal. But copying, I think, copying an archive blob to online tire has to be done with like calling the REST APIs. So, and the like the time to rehydrate, like there is also two, like the priority of the rehydrate process. So when we when we set a blob to rehydrate, sorry, when we set a blob to rehydrate, there are two ways that it can be done. There is a standard way which takes like 10 to 15 hours, and then there is a priority, like the high priority way, which will be done in 10 like an hour or two. But it can only be done for like a data which is less than 10 gigabytes. So let's just go ahead and check how we can rehydrate a blob. So first, let's upload something. When we try to upload a file, it will uh, ask us which container do we want to put the file in. So as we don't have any container currently present, we'll be just creating a one called new container. And when uploading a blob, we have uh, other options too. See, we have access tag. We can set it right here. Like when we upload a file, we get two options. We can set it to hot or cold or cool as we need. And hot tire is inferred, like it will be default to hot if we don't give it anything. So as we saw that our file got uploaded, we can go and view our files from this data storage containers, and this new container got created. This is our file which got uh, just uploaded by us. To change the access level of this file, we have to select it, click change access level. So not this change tire, and we can says archive is not supported. So, okay. So if the file was in archive, we could have come here and just set it to hot or cool as per our need. By this, we can change uh, the tires of a file. Going to uh, just to give an example. See, like we have archive tire here. So if we put it to archive, says it will make your blob inaccessible unless we rehydrate it back to hot or cold, which may take several hours. So save that. Now says to archive, then changing it again. It's hot. And it gives us a, when we change an archived blob to hot or cold, cool, we get an, like when we select hot or cool, we get an option to rehydrate priority. So when the standard one is selected, it says it will need several hours to be completed. And if we set it to high, like it will just get completed in 1 or 2 hours, but it will cost us more to rehydrate in higher priority. And it is also recommended by Microsoft that if we want to rehydrate our blobs, uh, we we should do them like big chunks, like big blobs to in a single go, so that we can save our time and the cost. So we can also set the lifecycle policies as by this JSON rule from our portal, and lifecycle policies for a container or a blob by going to a portal and selecting lifecycle management for our storage account. And in here we have add a rule option. By adding a rule, we get to select what will be the rule name that we want to set. I will just give it, and it gives us a scope, like do we want to limit it with filters, or it will be applied to all the blobs in the storage account. We select this, it gives us a tab for filter set, and what will be the blob types, which is block blobs and append blobs. Uh, so in block storage accounts, we have three types of blobs. One is block blobs, which is used for storing uh, like normal text and data, like text and binary data that we just uploaded, like a single image, which is a binary data. And we also have append blobs. Append blobs is best for storing log files, which is text-based data from a server, which will be like appended one after another as the logs come in from the server or any application that is hosted or there in on premise. Or then there is another blob, which is, there are three types of blobs. One is block blobs, one is append blobs, which is used for like getting logs for a server, or and then the last one is page blobs. So page blobs is used to store the virtual images of like virtual hard disk images, like when we have like an operating system running in cloud, like the ISO files of the operating systems should is stored in page blobs. So if we add the rule, it gives us an option to like set the rule, like what will be the action, like what will be the action. So if blobs were more than last modified value more than like 20 or 10 days, let's set to 10, then what should we do? Like if for 10 days the blob was not modified, then what should we do? Like should we delete the blob? We have option to move it to cool because currently it is in hot, and then delete it. Uh, as we saw that this storage account doesn't have an option to move to archive, it gives us these two options, which is called like cool storage or then delete. So I will select move to cold storage. Select next. Now it gives us an option to set the block prefix. This is nothing but what we saw here, which is this prefix match option inside the filters option. So let's say my container name is new container. And this one is any item that starts with picture. This rule will be applied to that. If we added, we get a rule that we just set, which is move to cool. We can select it and see what all options that were selected. And we can also move like we have two views, which is list view, which is this GUI type of a view, and we also have code view, which is this same options which we selected, but in JSON format. We have rules like we currently have a single rule, which is this. So we have a single item inside this rule array, and we set days after modification greater than 10, and also the prefix match is set to my new container / picture. Blob types is blob. So this is how we can use lifecycle management inside Azure storage containers or Azure storage accounts to like move like move tires for blobs to as per our requirements, and we can do this for all the blobs in a container, or and we can set as many rules as we want for a single storage account. And so currently now we have a single one. We can have many, and this rule will be applied to this storage account only, not any other account. So moving on to our last module, which is having an Azure .NET application, loading data files to our storage account, which we created right here, and then listing all the data types, like all the blob items, and then deleting it. So this is the code that we have currently. So to connect with our storage account, what we need is a connection string for our storage account. And how we will be getting this connection string is going to our storage account. We have security plus networking. We have access keys. We need to show keys, and here we have key one, which is and inside key one we have connection string. We just need to copy it, put it inside our variable. I have just copied current connection string and pasted it here, and we are just passing this connection string to blob service client, which is an object that will be authenticating us this application with the storage account that we created in Azure. and just go ahead and run this code. It says build succeeded. Now what we have here is the data that we'll be uploading is sample text file, which is hello world, and it resides in our project file inside this data uh, folder. And what we are doing in this code is we are creating a new container. As many times this code is run, like we are creating, as we discussed, like the container name has to be unique. So we are giving it a default, like a unique ID by calling GUID, and then setting it as our container name. And this will make sure that a container name is unique and doesn't get like collided with any other name container with the same name. Then what we are doing is creating the container, and we are doing it via this function, which is create blob container, and this is an asynchronous function, and we are passing the container name that we just like set it, like defined here. We are passing this as a container name, and we are returning the object, the client container object that we have created. Now what we are doing is getting the local file that we need to like that we need to upload, and then just writing it to, and then just uploading it via this function, the upload async function with upload file string. This contains like the file that we have. Then we are closing the connection. So till here, let's go through in our like by running the code. So going again to our container, we only have this new container that we created just now. As we'll be running this code, it says that the container name with 040 as this last letter has been created. Take a minute to verify. So the container name is already created, and that object is returned in this code to here. Like we have got the container client as it is created, and let's check in the Azure portal is if it is created or not. Here we can see with 040 in the end, a container name is created for us, where we will be storing the hello world text file. So if we just hit enter, it says uploading to blob storage as a blob. So this text file was is uploaded as a blob to our storage account, and it gives us a URL as a return parameter. Every blob that we upload to Azure storage account gives as a URL in return, a unique URL that will be used to identify that particular blob. So if we see, this is the name of our container, sorry, our storage account, which is Skycast session 3, which I just declared, and that will be the default name for all the blobs that will be residing in this storage container. And then we get this unique, the name of the blob, name of the container, which is 040. This is the name of the container that we just created. and then this is the file that we created. So this is the unique URL for every blob that will be uploaded in our storage account. So to check if the upload is successful, as it says here, we can go to our portal, refresh it, and see that we have a file here, which is uh, which is the same one that it says it uploaded in here. You can also check its contents, as it is a text file and preview is available. We can see the details when it was last modified in creation time, and uh, these all data fields were used as rules for life cycle management for our block. So these are important data points when it was last modified and created, and these are other uh, items properties for this block. You can see what all versions it was uploaded, snapshots, and this is the preview of the file, which it's now it says hello world. The next part in our code, what it does is it downloads the block in a local file and it renames it to downloaded at the end. So before downloading, I will just edit it. Save. Now this file is edited. See, it got edited. And in the versions also, in our local, it just says hello world. Doesn't say the welcome to this session that I added right now. So if I hit continue, it will now what it will do is it will be listing all the blobs that is there in our storage account. We currently have just one, and now it will download the blob, which got downloaded to our data folder. This one. It says welcome to this session. This part was added by me in the cloud portal. Now, as a cleanup process, it will be deleting the blob uh, by calling this function, and all the references to all these functions is available in Microsoft Microsoft references. Now we are deleting we are deleting the container by calling the container client object and then calling delete async, and then we are just deleting the file in our local source, the local files that we have. We can continue. It would have deleted the files. As we see, the downloaded file is now deleted. It just has the sample text one. Now if we go to this uh, container and hit refresh, it will give us an error because it is now deleted. It says unauthorized, but because it is now deleted, we no longer can access it. It is gone from our list of containers that we have. So thank you guys. That was all for this session. Any questions? Feel free to ask.
Thanks a lot, Rishabh. Just one question in terms of the accessibility of when you mentioned about the accessibility of the blobs. You mentioned that there is a private and a public access and an anonymous one. So, if these blobs are stored in a container, are they accessible over the public internet as well, or is it that always there should be authentication that needs to happen, and only then we can access the files?
I think we can give access to uh, other users by delegated access that we discussed right here by creating a shared access signature that will just be what we do in Google Docs or something like we create a link and that link is shared by other users. Like we set the visibility to public and the same thing I think can be done in blob storage. That will.
Okay. All right. Thanks a lot, Rishabh.
Thank you, sir. Any other questions?
Thank you, Rishabh. Thanks a lot for your time.
Thank you, everyone. Well, have a nice day. Bye.